and advice. In this video, let me discuss about problems in Fourier series. If a function f of x is given in an interval 0, 2 pi, then we are going to discuss how we are going to expand that function as a Fourier series in the given interval. So before let me enter into the problem, let me have a short look over the formulas that we are going to use in the problem. The very first, one of the important formula is Bernoulli's formula, or integration by parts formula that you have studied in your school days, right? That is integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus etc. Here both u and v are both functions of x, and also here u dash, u double dash and u triple dash etc. These are all successive derivatives of u. That is u dash is nothing but du by dx. That is, you have to differentiate u once with respect to x, and u double dash is equal to d squared u by dx square. That is, we have to differentiate that u 2 times with respect to x. If you are going to differentiate that thrice, that is 3 times with respect to x, that is u triple dash, so that is 3 times. So etc. So these are all successive derivatives, whereas v1, v2, v3 etc. these are successive integrals. So v1 is nothing but integral v dx, that is one time you have to integrate with respect to x. Again, if you are going to integrate v1 with respect to x, that is nothing but v2, which means you have to integrate v twice with respect to x. And v3 is integral v2 dx, that means you have to integrate v2 once again with respect to x, that means v3, that is here you have to integrate 3 times with respect to x etc. So here u dash, u double dash, triple dash etc. successive derivatives, whereas v1, v2 and v3 are successive integrals. So very important formula, you should know this formula for calculating the Fourier coefficients, and also by substituting the limits we should know the values of all this, that is cos n pi value is minus 1 whole power n, whereas cos 2n pi is plus 1, whereas in case of sin n pi, both n pi and 2n pi both have become 0 here, and here n is an integer, so in 0 to 2 pi, if n is an integer, this is an integer. So this value we have to apply. And let me have a short look over how the differentiation takes place and integration takes place by the differentiating x bar n and integrating x bar n. This is a well-known formula, integral x bar n dx is equal to x bar n plus 1 divided by n plus 1. By differentiating the same function with respect to x, that is d by dx of x bar n is equal to n x bar n minus 1. And one more thing, while integrating cos nx with respect to x, that is dx is equal to sin nx divided by n. While integrating sin nx with respect to dx, that is with respect to x, you get minus cos nx divided by n. So these are the things you should remember while we calculating the Fourier coefficient. And let me give you the short intro about how the Fourier series look like in terms of pi form, and how we are going to calculate the Fourier coefficients a0, an, bn using the formula, Euler's formula, right? So this is the general form of the Fourier series, and we make use of these 3 formula, that is a0, an and bn is equal, that is we make use of these 3 formula and we calculate these Fourier coefficient, and substituting this equation gives you the Fourier expansion of the given function. Okay. Now with this short introduction, let me now move into an example. Expand f of x is equal to pi minus x the whole square as a Fourier series in the interval 0, 2 pi. Here it is note that given function is f of x is equal to pi minus x the whole square, that is given in the interval 0, 2 pi. Am I right? So you may write using inequalities rightly like this, or you may write the same interval like open parenthesis or close parenthesis. Here the open interval, so that's why I have to use this open parenthesis. Okay. Now let me come to the problem. Now, here look at the function. This is pi minus x the whole square. So it is in terms of power 2. Some of the students, what they are going to do is they have to expand this function. That is pi minus x the whole square in the form a minus b the whole square, and expand that function. So if you are going to expand this part, you get a square plus b square minus 2ab. Okay, instead of a and b, here you have pi and x. That is pi minus x the whole square means you get 3 different terms. So by making use of that, they are going to calculate a0, an and bn. But that seems to be difficult. Okay, that seems to be difficult and lengthy process, I think so. So we have to work that problem, the same problem in a smart way, right? So what we are going to do here is, so here x is in the negative side, right? But the power is 2. What I am going to do next is, I am going to simplify my calculation. For that, what I am going to do here is, you just interchange this position, or you have to take minus 1 and outside. Whatever that maybe you have to take, that is both the same. So I am going to write this as x minus pi the whole square. Alright, these both two are equivalent. Right? Pi minus x the whole square means if you take minus outside, what happened? That is minus 1. If you take it outside, means that comes outside of this parenthesis with the power of 2. Right? The remaining you have, that is minus pi plus x the whole square. That is minus 1 square is plus 1. So you have to write positive plus and negative term next. You get x minus pi the whole square. So I have to directly write like this. Okay. So pi minus, since the power is 2. If the power is in terms of all numbers like 1, 3, 5, I could write like this. Okay. So if the power is 2, so negative minus 1 become positive. That's why I am going to write like this. Okay. Next, so by making use of this function, so listen carefully, this is only difference. So from the given function, in order to make my calculation part seems to be very simple, I want to make my calculation part in a simpler way. So for that, I have to rearrange or rewrite the given function like this. Here both are same, right? Now, as usual, let me first write down the general form of Fourier. So that is f of x is equal to a0 by 2 sigma n is equal to 1 to infinity an cos nx plus sigma n is equal to 1 to infinity bn sin nx. You take this as equation number 1, where we make use of the 3 formulas. That is a0 is equal to 1 by pi integral 0 to 2 pi f of x dx. You take this as equation number 2, and the an is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. Take this as equation number 3, and bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. You take this as equation number 4. So by making use of these 3 equations, that is 2, 3, 4, we calculate the Fourier coefficient and substitute in equation 1, the problem will be over. So let me first see how to calculate the value of a0. So a0 is equal to, from equation 2, your a0 is equal to 1 by pi integral 0 to 2 pi f of x dx, that is which is equal to 1 by pi. You are given f of x is, that is x minus pi the whole square. I have to rearrange this function like this. So x minus pi the whole square dx. By integrating, what I am going to get here is, that is, you know already, integral x power n dx is equal to x power n plus 1 divided by n plus 1. The same formula here we have to use. So here instead of x we have additionally x with minus pi. Okay, minus pi here is a constant. So x minus pi the whole cube divided by 3 with the limit from 0 to 2 pi. Okay. So here you have 2. So if you add 1, so 2 plus 1, 3 divided by 3. So this is equals 1 by pi. Let me substitute the limit. First we have to substitute upper limit and then minus lower limit. If you are doing so, that is for x term. So upper limit 2 pi minus pi the whole cube divided by 3 minus 0 minus pi the whole cube divided by 3. You replace this x term by 0, you get this term. Okay. Now simplifying this, you get 1 by pi. 2 pi minus pi is nothing but pi itself, that is pi cube divided by 3 minus of here. So listen carefully, 2 pi minus pi is plus pi, that's why plus pi cube. Here you have minus pi. If you cube that minus pi, you get minus of pi cube, right? Divided by 3. So this 2 minus becomes plus, that is 1 by pi. So pi cube divided by 3 plus pi cube divided by 3, that is 1 by pi of 2 pi cube divided by 3. So one of the pi being cancelled. So your a0 is equal to 2 pi square divided by 3. This is the value of a0 you have calculated. Next we calculate the value of an. From equation 3, your an is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. Okay. Now your f of x is nothing but x minus pi the whole square. Am I right? So it is equal to 1 by pi integral 0 to 2 pi. Your f of x is x minus pi the whole square cos nx dx. This is your u and this is your v. Since this is a product of two functions involving the variable x, so we wouldn't integrate this directly as we do in case of previous, that is calculation of a0. So for that we make use of the formula, Bernoulli's formula, that is uv dx is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus etc. Whenever the derivative term becomes 0 means we have to stop. This is an infinite series. Okay. So whenever the derivative of that is u double dash or u triple dash becomes 0 means we have to stop up to that. Okay. Here I have to take the first term, that is u as x minus pi the whole square and v as cos nx. So now I am going to differentiate u with respect to x, that is u dash. U dash is equal to this of the form, you know, d by dx of x power n is nx power n minus 1. Am I right? So nx power n minus 1, that is 2 instead of x you have x minus pi. Okay, pi here is a constant. So 2x minus pi whole power 2 minus 1, product here x, that is while differentiating again x you get 1. So no need to differentiate once again x. Okay, leave it because having x power 1, so that is understood that in multiple it has 1. So you have u dash is equal to twice x minus pi and u double dash is equal to, while you differentiating this with respect to x once again, so what can happen is pi is a constant. So first we have to do product. While you differentiating x you get 1 minus differentiating a constant here becomes 0. So u double dash is 2 itself and u triple dash is 0 because while differentiating a constant you get 0. So we have to stop this procedure after this. So since u double dash is equal to 2 and u triple dash becomes 0 means we have to stop this formula up to this. So we have to calculate v1, v2 and v3 only. Okay. Now here v1 is equal to, that is integrating cos nx with respect to x. While integrating cos we get sin nx divided by n. Next v2. v2 is nothing but you have to integrate v1 once again with respect to x. This is your v1. So if you integrate this, 1 by n is a constant, you take it outside of the integral. So integral sin nx dx alone. So if you integrate sin nx you get minus cos nx divided by n. Already you have n in the denominator, so that becomes n square in the denominator. Next, V3. V3 is nothing but you have to integrate V2 once again with respect to x. So here 1 by n square, that is minus 1 by n square is a constant. So take it outside of the integral and just integrate only cos nx. So when integrating cos nx dx you get sin nx divided by n. Already you have minus term and n square in the denominator, so that becomes n cube. So this is your V3. So now let me evaluate this integral by making use of these u dash, u double dash, that is derivatives and integrals of v, that is now we have calculated. Okay. Now, so a is equal to 1 by pi uv1. U is nothing but x minus pi the whole square. Here v1 is sin nx by n minus uv1. Next one u dash v2. U dash is twice x minus pi. v2 is nothing but minus cos nx divided by n square plus u double dash. U double dash is 2 v3. v3 is minus sin nx divided by n cube. So with the limit from 0 to 2 pi. So before we are going to apply the limit, let me first simplify the symbols. So here there is a minus, so plus minus becomes here minus, here minus minus becomes plus. So let me simplify that so that the calculation part seems to be easy. Okay. So x minus pi the whole square sin nx divided by n plus twice x minus pi of cos nx divided by n square minus twice sin nx by n cube. So with the limit from 0 to 2 pi. So let me substitute the limit, that is upper limit minus lower limit as usual, that is 1 by pi. Let me substitute first upper limit. If you substitute for upper limit first, what happens here? So this is for upper limit, okay? So minus lower limit minus lower limit. I just put the parenthesis first. So this is for upper limit minus and lower limit. First you replace the value of x by 2 pi. So these are all the questions we have x. Okay. So look at the first term. If you replace this x by 2 pi, what happens? Sin 2n pi. You know the value of sin 2n pi. What is the value of sin 2n pi? 0. If this term becomes 0 means the entire term becomes 0. The first term is 0. Plus cos 2n pi. You know the value of cos 2n pi. Cos 2n pi is plus 1. So cos 2n pi is plus 1. So here 1 by n square. So if the product you have twice 2 pi minus pi. Minus sin 2n pi again. If you replace this x by 2 pi, you get sin 2n pi. So this term becomes 0. Minus, coming to the lower limit. So here itself, if you replace this x by 0, sin 0. Sin 0 becomes 0 means the entire term becomes 0. So the first term becomes 0 because sin 0 value is 0. Plus twice 0 minus pi, and just replace this x by 0, and cos 0 value is 1. You know already cos 0 is 1. So 1 by n square minus 0. Because sin 0 value is 0, so this term becomes 0. So let me simplify this. That is 1 by pi twice pi of 1 by n square, because 2 pi minus pi is pi. Upper limit minus, coming to the lower limit, twice minus pi of 1 by n square. So these 2 minus becomes positive. So 1 by pi of 2 pi by n square plus 2 pi by n square. So you have 1 by pi of 4 pi pi n square. So one of the pi being cancelled, so you get only 4 divided by n square. So this is your an. So an is equal to, so your an is 4 by n square. Okay. So after calculating an, let me now move on to next one. That is, we have to calculate the next Fourier constant Bn. For that, we make use of this formula. That is, Bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. So let me now first replace the given function f of x by, that is 1 by pi 0 to 2 pi. Let me first replace the given function f of x by x minus pi the whole square, that is x minus pi the whole square sin nx dx. It's a product of two functions, so we couldn't integrate directly, so that we make use of the Bernoulli's formula, that is integral uv dx. Okay, integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 plus minus u triple dash v4 plus etc. So we make use of this formula. The same function here itself we take in terms of calculation of an, that is u is equal to x minus pi the whole square. The same function there itself we take as u. So there is no change in the integration of u dash and u double dash that we calculated as before. And only the change here is that we take cos nx as v, but here we take sin nx as v. So v is equal to sin nx. Okay. So u is equal to x minus pi the whole square. Let me first differentiate this. So u is equal to x minus pi square, and u is equal to twice x minus pi, and u double dash is equal to 2, and u triple dash becomes 0. Since this becomes 0 means we have to stop this procedure up to this. That is, we have to stop the formula up to this. So we calculate v1, v2 and v3 only. So v1 is nothing but integral sin nx dx. While integrating sin nx, you get minus cos nx divided by n. v2 is nothing but, again you have to integrate v1 once again with respect to x, that is you take minus 1 by n constant outside, so you get only cos nx dx. So integrating cos nx with respect to x, you get sin nx divided by n. Already you have one more n in the denominator, so that becomes n square, also minus in the beginning. Okay, you add that. Next, you have to integrate this term once again with respect to x, that's our b3. So you have to take minus 1 by n square as a constant, take it outside and integrate sin nx. While integrating sin nx, you get cos nx, that is minus cos nx divided by n. Already you have minus at the beginning, so that minus and minus becomes positive already, and also you have n squared in the denominator. So here you have one more n, so that becomes n cube. So now let me now substitute this in the formula in the form u v1 minus u dash v2 plus u double dash v3, and let me substitute the limits 0 and 2 pi to get the value of bn. Okay, so your bn is equal to 1 by pi of u is x minus pi the whole square, and v1 is minus cos nx by n minus u dash is twice x minus pi v2 is minus sin nx by n square plus u double dash is 2 and v3 is cos nx divided by n cube with the limit from 0 to 2 pi. So before we are going to substitute the limit, let me simplify the symbols. Here there may be 2 minus, so that become positive. So you take this minus at the beginning of the term. So let me simplify these symbols in our next step, that is 1 by pi of minus x minus pi the whole square cos nx divided by n and plus twice x minus pi of sin nx divided by n square plus twice cos nx divided by n cube. Here the limit from 0 to 2 pi. As usual, you have to substitute the limit like upper limit minus lower limit. So first we substitute the upper limit, that is 2 pi. This is equal to 1 by pi, the big parenthesis, and you have a sub parenthesis in this form. So minus of cos 2n pi becomes positive, so you have to replace this x by 2 pi. So 2 pi minus pi the whole square, and if you replace this x by 2 pi, you get cos 2n pi. So that is 1 divided by n plus, if you replace this x by 2 pi, your sin 2n pi is 0, so second term becomes 0 plus twice cos, if you replace this x by 2 pi, cos 2n pi, that is 1, so 1 by n cube. So upper limit over minus, coming to the lower limit. So if you replace this by x by 0, minus of 0 minus pi the whole square of 1 by n, because cos 0 is nothing but 1. Plus second term becomes 0 because sin 0 becomes 0, so entire term becomes 0 plus twice 1 by n cube. Okay, let me close this. Now, because cos 0 is here becomes 1, so you get 1 by n cube. So this is equal to 1 by pi. Let us simplify this. So minus of 2 pi minus pi is pi itself, so you get pi square divided by n, okay, plus 2 by n cube minus, coming to the lower limit, here you have pi square, so plus pi square, so here that before that you have minus term, so minus pi square divided by n plus 2 by n cube. If you take this minus inside, what happens here is 1 by pi minus of pi square by n plus 2 by n cube plus pi square by n minus 2 by n cube. So all these terms becomes cancelled because minus 2 by n cube plus 2 by n cube. Pi square by n minus pi square by n. So what happens here? Which implies Bn is equal to 0. Okay. So all of them become cancelled, which means 1 by pi of 0. That is 0. So Bn is equal to 0. So there is no value of Bn. So let me now substitute all these values in equation 1. So the value of A0 we have calculated is 2 pi square divided by 3, and An is equal to 4 by n square, and Bn is equal to 0. So let me substitute all these values in equation 1. Substitute in equation 1, we get f of x equal to A0 by 2. A0 is 2 pi square by 3 divided by 2 plus sigma n is equal to 1 to infinity. An is 4 by n square cos nx. Here Bn becomes, this term becomes 0, means the entire term becomes 0 because the value of Bn becomes 0. So here cancelling the value of 2 both in the numerator and denominator. So you get pi square divided by 3 plus take 4 outside, sigma n is equal to 1 to infinity because that's a constant, 1 by n square cos nx. So this is the Fourier series expansion of the given function f of x is equal to pi minus x the whole square, that is given in the interval 0, 2 pi. Okay. So up to this, hope you got a clear idea about how to expand the given function. If it is in terms of power 2, okay, and how to calculate the Fourier coefficients using the Bernoulli's formula. Thanks for watching. See you all again in my next video.